Hello everyone. In this video we are going to discuss about network devices and we'll be seeing different network devices such as modem, repeater, hub, switch, router, bridge, gateway, etc. Now let's see what is a network device. Network devices are used to connect computers, printers, fax machines and other electronic devices to a network. These devices transfer data in a fast, secure and correct way over same or different networks. Network devices may be internet network or intra-network. Example for devices are NIC RJ45 which are installed in the device and some are a part of the network like router, switch, etc. First device, modem. Modem is a device that enables a computer to send or receive data over telephone or cable lines. The data stored on the computer is digital, whereas a telephone line or cable wire can transmit only analog data. The main function of the modem is to convert digital signal into analog and vice versa. Modem is a combination of two devices, modulator and demodulator. The modulator converts digital data into analog data when the data is being sent by the computer. Demodulator converts analog data signals into digital data when it is being received by the computer. Next device is CSU or DSU. CSU/DSU stands for Channel Service Unit, Data Service Unit. It is a hardware device which is equivalent of the modem for an entire LAN. It is a digital interface device used to connect DTE, that is data terminal equipment such as router to a digital circuit. CSU/DSU implements two different functions. CSU is responsible for the connection to the telecommunication network, while DSU is responsible for managing the interface with the DTE. Next device is a repeater. A repeater operates at the physical layer. It is a two-port device. Its job is to regenerate the signal over the same network before the signal becomes too weak or corrupted. They do not amplify the signal. When the signal becomes weak, they copy the signal bit by bit and regenerate it at the original strength. Hub. A hub is basically a multi-port repeater. A hub connects multiple wires coming from different branches. Hubs cannot filter data, so data packets are sent to all connected devices. They are not intelligent devices to find out best path for data packets, which leads to inefficiencies and wastage. They act as pathways to direct electrical signals to travel along. Hubs transmit the information regardless of the fact if the data packet is destined for the device connected or not. Hub can be an active hub or a passive hub. Passive hubs are more like point of contact for the wires to build in the physical network. They have nothing to do with modifying the signals. Active hubs are smarter than the passive hubs and they not only provide the path for the data signals, in fact, they regenerate, concentrate, and strengthen the signals before sending them to their destinations. Next device is bridge. A bridge interconnects two LANs working on the same protocol. A bridge is a device that builds the connection with the other bridge networks which use the same protocol. It works at the data link layer of the OSI model and connects the different networks together and develops communication between them. A bridge is a repeater with add-on functionality of filtering content by reading the MAC address of source and destination. It has a single input and single output, thus making it a two-port device. Bridges forward the data after inspecting the MAC address of the devices connected to every segment. It has the capacity to block the incoming flow of data as well. Switch. A switch is a multi-port bridge with a buffer and a design that can boost its efficiency and performance. Switch is a data link layer device and it can perform error checking before forwarding data. That makes it very efficient as it does not forward packets that have errors and forward only good packets selectively to correct port. It uses packet switching technique to receive, store and forward data packets on the network. Switch maintains a list of network addresses of all the devices connected to it. On receiving a packet, it checks the destination address and transmits the packet to the correct port. Before forwarding, the packets are checked for collision and other network errors. Switches are the linkage points of an Ethernet network. Hub works by sending the data to all the ports on the device, whereas a switch transfers it only to that port which is connected to the destination device. A switch does so by having an inbuilt learning of the MAC address of the devices connected to it. Since the transmission of data signals are well defined in a switch, the network performance is consequently enhanced. Switches operate in full duplex mode, where devices can send and receive data from the switch simultaneously. The transmission speed in switches is double than in Ethernet hub. Higher data speeds are achieved on networks through the use of multiple switches, which in turn improves the performance. Another important network device is a router. A router is a device like a switch that routes data packets based on their IP addresses. It has the ability to connect dissimilar LANs on the same protocol. They process logical addressing information in the network header of a packet, such as IP addresses. Router is mainly a network layer device and it has the ability to limit the flow of broadcast. A router primarily consists of a hardware device or a system of the computer which has more than one network interface and routing software. Router also strengthens the signals before transmitting them. That is why it is also called as a repeater. Routers normally connect LANs and WANs together and have a dynamically updating routing table based on which they make decisions on routing the data packets. The functionality of a router. When a router receives the data, it determines the destination address by reading the header of the packet. Once the address is determined, it searches in its routing table to know how to reach the destination and then forwards the packet to the higher hop on the route. The hop could be the final destination or another router. Routing tables play a very pivotal role in letting the router make a decision. Thus, a routing table is ought to be updated and complete. Routing table. A router reads its routing table to decide the best available route the packet can take to reach its destination quickly and accurately. Routing tables are of two types, static and dynamic. Static. In a static routing table, the routes are fed into the routing tables manually. It becomes a time-taking task and also error-prone. It is suitable only for very small networks. Dynamic. In a dynamic routing table, the router communicates with other routers through protocols to determine which routes are free. The purpose of these protocols is to enable the routers to transfer information about other routers so that the routers can build their own routing tables. It is suited for larger networks. Next is a router. Routers are the combination of both the bridge and router. They take up the functionality of both networking devices, serving as a bridge when forwarding data between networks and serving as a router when routing data to individual systems. The final network device we are going to discuss about is gateway. Gateways connect dissimilar networks which uses dissimilar protocols. They basically works as the messenger agents that take data from one system, interpret it and transfer it to another system. Gateways are also called protocol converters and can operate at any network layer. They are generally more complex than switch or router. Gateway forms a link between different networking systems or computer programs. It allows the computer programs, either on the same computer or on different computers, to share information across the network through protocols. I hope you got the differences between all the network devices we have mentioned in this video. Thank you.